As we continue to talk about simplifying exponents, the next thing we're going to talk about is what happens when we have a quotient to a power or when we divide exponents. We talked about raising a quotient to a power today in class, or the other day in class actually. I mentioned that it falls in terms of your flow map, it falls into step 2. So it's part of the distributing. So we talked in class about how we can distribute in when we have multiplication. We can also distribute in when we have division. So a over b raised to the n is the same thing as saying a to the n over b to the n. So if I look at this first example here with it, if I have c over 2 squared times b cubed, all raised to the 4th power, I'm going to take that 4th power and I'm going to distribute it to the c, to the 2 squared, and to the b cubed. Remember, when I distribute it to the 2 squared, I'm going to multiply my exponents. Same thing when I distribute it to the b cubed, giving me c to the 4th all over 2 to the 8th, b to the 12th. From here, I continue moving through my flow map. I check to see if I have any negative exponents. I don't. I check to see if there's anything I can multiply. I can multiply 2 to the 8th out. It's 2 times 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 2. 8 times, which is going to be a really big number. Specifically, it is c to the 4th over 256 times b to the 12th. So again, just demonstrating how I can distribute that in when I do have a quotient or a division problem raised to a power. The next thing I want to talk about with fractions and exponents is reducing and dividing. We've already looked at that before. If you think about when we factored, we were dividing with exponents all the time. So if I look here, if I have 3x to the 5th over 6x squared, one thing to be careful of that I see people make mistakes of all the time is that they start intermixing their rules for numbers and their rules for exponents. So when you see 3 over 6, you've worked with fractions like 3 over 6 many times. So I can reduce both of those by 3, so I'm just reducing like normal, which would give me the 1 on top and the 2 on the bottom. When I look at x to the 5th over x squared, now with my exponents, I'm going to do a little bit of scratch work over here. Think about what we did when we were factoring. We said, what do? I do x 5 times, because that's what the definition of x to the 5th is. I do x twice, since that's the definition of x squared. 2 of my x's cancel, leaving me with x times x or x cubed, specifically leaving me with x cubed on top. So I have 1x cubed over 2. 1 times x cubed is the same thing as just saying x cubed over 2 for my simplest answer. Looking at the second example here, similar. I don't have any numbers this time, but I do still have variables with same base. So I have x cubed over x to the 8th. So if you want to, you can write it out just like I wrote it out in that first example, or you can just think about it in your head. If I have 3 x's on top, I have 8 x's on the bottom, how many x's do I have in common? How many x's will cancel? Well, won't 3 of them cancel? And if that happens, how many are left and where are they left? Well, I'm left with 5 on the bottom, which I know in exponential form is x to the 5th. I can't just have nothing on top. I can't have floating space, so I have to fill that space with something. I'm going to fill it with a 1. Reducing to 1 over x to the 5th. So now that we know our whole flow map. So we've kind of been uncovering one piece at a time. So the last piece that we had was this step 5, and it's doing this. It's reducing if we have the same bases. So if we look at, I believe, 2 examples I have where we use this entire flow map. I'm going to go ahead and look at the first example where I'm asked to simplify this expression. First thing I check for moving through my flow map is, do I have anything raised to the 0 power? It doesn't look like it. So I'm going to move across and ask myself, do I have anything I can distribute? Well, yeah, I do. I can distribute this 3 here on the outside to every single component on the inside, giving me c to the, I multiply my exponents, so to the 6th, d to the, multiplying my exponents to the 9th, c to the 15th, and d to the negative 12. Moving along my flow map, the next thing I want to do is fix my negative exponents. I do that by moving my base. So I do only have one base that has a negative exponent. It is d to the negative 12. So it will travel up. Remember, when it travels, it gives up its ticket, giving me c to the 6th, d to the 9th, d to the positive 12, all over c to the 15th. I've now completed steps 1 through 3 of my flow map. Looking at step 4, I need to multiply if I have same bases. When I do that, I add my exponents. Well, I notice right here I have d to the 9th and d to the 12th. Those are same bases, so I'm going to loop down here, giving me c to the 6th, d to the 9 plus 12 is 21, all over c to the 15th. So finishing that last step that we've now learned, I'm going to reduce because I do have a d on top, or excuse me, I do have a c on top and c on bottom. Well, if I have 6 c's on top and 15 c's on the bottom, 6 of them are going to cancel. 15 minus 6 is going to tell me how many I have left. And notice, because I had more on the bottom, the amount that I have left are going to be on the bottom. So I'm going to have d to the 21 all over c to the 9th. Since d and c are not same bases, that's the best I can do, and that is my final answer. Looking at the next example, so I still have my flow map up here because I'm always going to use my flow map. Next example, I'm going to go through the same process. I'm going to check and see, do I have anything raised to the 0 power? Doesn't look like it. Do I have anything I can distribute? It looks like on top I can distribute this 3 to all 4 of these, and on the bottom I can distribute the 2 to the 2, the y, and the z. I remember that when I have power to a power, I multiply, and this gives me 2 cubed, x to the 9th, y to the negative 9, z to the 3rd, all over 4x to the 7th, 2 squared, y to the negative 6, z to the 8th. So again, I distributed that 3 to everything on top and these last 3 parts on the bottom. Notice that distributing gets rid of my parentheses. So now that I've done steps 1 and 2, I'm going to move to step 3. I do see I have a couple negative exponents, and I'm going to have to fix the y on top and the y on the bottom. So moving those, I'm going to now have 2 cubed x to the 9th, z cubed still on top, and then y to the 6th comes up. Remember, it travels and it gives up its ticket. 4x to the 7th, 2 squared, z to the 8th are all still there, and then the y to the 9th comes down. From there, I move to step 4, which tells me I can now multiply. So on top, I can figure out what 2 cubed is. 2 times 2 times 2 is 8. None of the rest of these are same bases. X, z, and y are all different bases. On the bottom, I have a 4 and a 2 squared. Well, I know 2 squared is 4, so technically I have 4 times 4, which is going to give me 16. And then again, that's my only like base, so I'm going to have 8 on top, x to the 9th, z cubed, y 6th, all over, again, 4 times 4, so 16, x to the 7th, z to the 8th, y to the 9th. Moving on to my final step, I'm going to reduce same bases. X to the 9th over x to the 7th. Actually, before I reduce my exponents, I'm going to reduce 8 over 16. The 8 is going to cancel. The 16 is going to turn to a 2. X to the 9th over x squared. X to the 9th over x to the 7th. 7 of them will cancel, leaving me with x squared on top. Z cubed over z to the 8th. 3 of them will cancel, leaving me with z to the 5th on the bottom. Y to the 6th over y to the 9th. 6 of them cancel, leaving me with y cubed on the bottom for my final answer. I thought I had 2 examples. I guess I have 3, so moving on to the last example. This would be a good one for you to pause and try on your own, and then go ahead and hit play and see if you were able to come up with the correct answer. Especially those of you who come in and when we do the clicker problems are struggling with those because you haven't tried one on your own yet. Again, this would be a good one to try. Okay, now that you've had a chance to try the problem, let's see how you did. So first thing you did hopefully was check for x to the 0. Nothing's raised to the 0 power. Hopefully the second thing you did was to see if you could distribute anything into, any exponents into your monomials. I notice on top I don't have anything to distribute, but on bottom I can distribute the -2. So I'm going to go ahead and leave the top alone. And on the bottom, when I distribute the -2, I get 3 to the -2, a to the -4, b to the +4, c to the +8. Moving across my flow map, I see the next thing I want to do is fix my negative exponents, so I'll move this b down. I have to move the 3 up. The biggest mistake I see is people either want to call that -9 or they want to call it -6. I have to fix my negative exponent before I can evaluate that. I'll bring my a up. Notice I don't bring my -4 down. I don't fix negative numbers, just negative exponents. Doing that gives me -4 a cubed 5c 5, and then the 3 comes up and the a comes up. On the bottom, I still have b to the 4th, I still have c to the 8th, and then b to the squared comes down. Now that I fixed my negative exponents, I can multiply. I know that 3 squared, so I know I have -4 times 5, which is -20. I know that I have a cubed times a to the 4th. I add and get a to the 7th. C to the 5th. I also know that 3 squared is 9. On the bottom, I get b to the 4th times b squared. Adding, I get b to the 6th times c to the 8th. I notice now that I also have a -20 and a 9 I can multiply, so I'm actually going to do that as well. So -180, a to the 7th, c to the 5th, b to the 6th, c to the 8th. Taking my last step, step 5, I'm going to reduce same bases. I see the only thing that gives me to reduce are my c's. 5 c's over 8 c's, 5 of them cancel. I'm left with 3 on the bottom. So my final answer is -180 times a to the 7th all over b to the 6th, c to the 3rd. And since I have went all the way through my flow map, I have my final answer.